How's it going, everyone? Small here. So I spent the last decade building and fixing production systems. Basically everything from the model at the top, like down all the way down to the metal. And in this specific video, I want to walk you through one of the most common failures that I've been seeing when it comes to AI agents. This error is about like when your AI agent tells you it's actually called a tool, then the run comes back looking successful, and yet nothing actually happened. So in that case, almost everybody blames the AI model for this, and almost like everybody is wrong here. So let me show you exactly what's really going on here and how to fix it. Okay. So, so here's the situation here. And like if you built anything with agents before, you're almost certainly seen this before. So your agent would tell you it's called a specific tool. The run would comes back green. It says success, and the thing you actually asked for would never happen in the first place. And the what makes this even like more annoying is that like there's nothing to grab into because system is showing no error, no stack traces. Basically, like there's nothing in the log that even looks wrong. Like even that's slightly wrong. Everything looks so good. And basically, like yeah, the whole system looks clean. Everything runs successfully, although like nothing on the other end of this run. So what what will end up happening naturally is like the first thing that you would ask is okay, so which part exactly lied to me here? So and okay, now so let's try to answer this. So basically, like when you go back, this is what you would find here. Okay, let me zoom in a little bit more. So on the side you've got like the run logs, and every single run shows that screen everything's completed successfully. Basically it also shows that it planned the call, it emitted the call, it closed the stream, it finished the turn, statue is success, everything checks out. But like over here is what actually happened out in the real world. So zero API calls, zero database writes, zero email sends, and basically nothing moved at all. And this is the trap here, like right here in this section, because like every instrument that you have is actually telling you it's worked. So when something is clearly broken, but every single signal like says it's fine, what ends up happening is like you just like start hunting everywhere except the only place that actually was broken in the first place. Okay, so let's actually go find where like it actually was broken in the first place. So this is like the model produced. Okay, so let's say tool name. Let me zoom in a little bit more. Yeah. So tool name, the arguments, city, everything is correct, as you can see. So basically, for this case, it's complete, it's valid, and the model did exactly what it was asked to do in the first place. So based on that, like every failure is like everything that would happen after this point forward. So everything that happened to the output once the model has handed off to the next thing, and that's the part that almost nobody would look at in the first place, because this isn't like clever at all. Like this is not the intelligent part, just like the boring and the part that would most people would just like ignore, and that's what where actually would be broken 99% of the times here. And just to see like how that actually would happen, so what you need to do is actually you need to understand what a tool call actually is. because it's not what most people would picture this, because like a model, like an AI model, can't run anything, does not have any hands, cannot do anything by itself. All it can do is, well, like when it calls a tool, it's just like calling, is what ends up happening is actually it's not calling anything at all. Basically, think of the AI model here as like a waiter. So all it does is taking your order. It does not cook. It does not do anything else. Just like take your order and just like write the order down. Then that slip, like right here, this is like your order, and basically this is the tool call. And just like a pure text, pure JSON object. It's nothing it's nothing fancy about it. And like what ends up happening is like then this receipt, this slip would be given to the cook, which would handle everything going forward. So basically the cook would read the slip and actually makes the dish. So like the model writes just like writes the order, and the cook is your code, which actually would execute the actual thing. Yeah. So basically these two things have different jobs, and these two exist in two different places and two different universes. So the obvious question here is like, what happens when the order gets write down by the waiter? In your case, in our case, it's the model, but it would never reach the cook or the code that would execute the tool in the first place. Okay, so this is what happens. So as you can see, the order would be like what gets written, and somewhere along the way it maybe falls on the floor. So basically like the cook would never seize it, so the cook would never cook in the first place. And meanwhile the customer would just like gets told that their food, their order is on the way, except it will never be coming because the cook does not even know it exists. Now, here's like what I really want you to notice in this slide. So, if you go to look at the mistake here, and honestly, there aren't any like mistake you can actually point to here. So the waiter did a job, the model did a job, it wrote the order correctly. The cook was ready and willing to cook. So basically, like nobody made an error here, because like from each of these two parts of the system perspective, like the waiter, the cook, each of them were standing correctly. Everything went perfectly fine for them, although nothing would worked in the first place. And that's actually the reason why this is so hard to catch, and this is why this is like a silent killer for agent systems here. Okay, so now like the most common place the order gets dropped is actually like right while it's being written, and to really get it, you need to know like one thing about how the AI model sends it over in the first place. So the AI model doesn't hand you the whole order in just like one go. So basically it streams it to you, one little piece of data at a time. So the first piece would, for example, shows up, would say like, hey, tool is coming, and here's its name. Then like it will send another one like get weather. Then like a moment later the arguments will start arriving. Just everything happens like a bit just over time. Does not happen immediately like all together. So all the data would be streamed in a different timeline. And here's the mistake that caused all this to happen. So basically like the harness would read the arguments, and the instant that first piece would land, and basically like it would just like read the tool name before all arguments are at the place. So basically watch what that would do here. At the exact moment the arguments actually would be empty string, So when you parse an empty string, what ends up happening is you get an empty object, and an empty object is perfectly valid. That's true. If you give it like nothing, the output would be nothing. So the tool would not execute anything, and it have all right to do that. So from the outside perspective, the tool would look like it finished its work, and although like there will be no outputs, which is also correct at the same time. So that's like really the whole bug here, and just like in just one line, an empty field doesn't get read as not ready yet. What ends up happening is like that field gets read as there's nothing here. So basically, like the the tool would read that and produce nothing, and that's also correct as output. And that's like the same basic mistake, which is like acting on something before it's actually ready. And this mistake actually like shows up in 5 different places between the model and the actual tool. So let me walk you through all these 5 of the most common reasons that your system may have this issue right now. That way you can understand better which one is your case, and you can debug it and fix the issue right away. So first, let's start by the whole picture here. So basically, the model would writes here like on the left, the tool would runs on the right, and everything in between these is where the order can get actually dropped here. So basically, it gets read, it gets sampled, it gets carried across the network, it gets signaled as finished, and it gets checked. So these like the 5 points, the 5 places, and the 5 stages where the input from the model to the tool can get dropped, and everything gets wrong. Although it will show you that the tool successfully did its job. But actually, before we go through all of these 3 different cases, I want you to let go of just like one major assumption here, because what basically because like based on my experience, that like this specific assumption would send you down the wrong path every single time, and none of those 5 issues is the AI model being too dumb at all. Like in any like in every one of these situations, the model already did the job, already like wrote the correct order, so it does not have anything to do with with this like mistake at any way possible. Which is like the whole reason here that throwing a bigger, smarter model won't even fix this issue in the first place. So let's get through these 5 common issues, so you can understand better which one is your specific case and how you can solve them. So the first cause here, and this one is the most common one by far, and actually it's like a streaming problem, and we already talked about it, so let's just like look it up more up close. So basically, here are the chunks coming in, as you can see here. So look at the first one here. The name is there, get weather, but the issue here is like the arguments are still just an empty string. They haven't been streamed yet, and because like the rest of it hasn't streamed in yet, that's like the moment the harness would goes and parse it as an empty string. So the empty string becomes an empty object, and the empty object looks valid, and everything looks done, although nothing gets fired in the first place. So basically, like the tool would fires empty arguments, and then with chunks 2 and 3. So the actual, like for example in this case, the actual city we just asked about, and just like show up a moment later, but whereas the tool already fired, so that's already too late. that's like basically the issue in the nutshell. It basically sent no inputs at all, and nothing along the way noticed that there were no inputs been sent to the tool. And like if you like ever work close to the hardware, this is going to feel like really familiar here because it's a classic race condition. So the statue register says byte is ready. The ready like flag is high, but the data register hasn't actually attached that byte yet. So if you read even like one cycle too early, you just like get stale data, or maybe you even like get nothing at all. So the flag went up before the data was really there, and it's the exact same failure, just like one layer further down. So this is like the second cause. Now, now for the second one, basically shows up when you've got two tool calls in a single turn. So what's the index on each chunk here? So every one of them says index 0. So basically what ends up happening is like the first call and the second call are both tagged the same way, and when the code goes to assemble them, it just like group them by the index, which means that both calls get dropped into the same slot, and the second one just overwrites, and maybe like the second one will just like overwrites the first one. So basically like you just like ask for two things to happen, and one of them quietly disappeared before anything even tried to run it in the first place. And here, like if you've done any networking before, you already know this one before. I'm talking about networking from IT, not networking as like sales to get to know people. If you're not, just to clarify this point. So basically, like for TCP would put a stream of packets before a back like together using their sequence number, and here like every single segment is carrying the same sequence number. So the stack either switches them together in just like one wrong order, or it maybe like even collapse them into just one. So basically like wrong thing to group by, or which would produce wrong result. So this is like the same failure again, just like one layer down. Now let's move to the third reason, which is like here. This one is actually interesting here because like this one isn't about the code itself, and it's not even about the model either. It's actually about something sitting in between the code and the AI model. So basically the model which speaks in one format, and you can see the function here, like the function calls hidden right here, like right there in it, but there's like a proxy in the middle translating that into a different format, and by the time it comes out the other side, it will comes up wrong. So basically like the tool call is just like gone at that time, and just like dropped into the translation because that field had nowhere to map it. And the tell here for this one is actually really specific. So if you call the model directly, it would works perfectly, but the moment you run it through your own stack, it will just break. So that's the tell for this specific case. And also for this one is actually a problem that every protocol engineer has run into it before. So basically, for this type of problem, the pattern here is like you would have gateway sitting between two different wire formats. Let's say header, body, and trailer, but the trailer has no equivalent on the other side. So the gateway will just like drops it into the way like through the translation from one side to another. So that would works when you talk directly, but it will breaks the moment you go through the middleman. So this is the same failure, just like one layer down. Now for the fourth cause, and this one is actually super sneaky here because the tool call itself actually completed fine, and the problem here is the little flag that tells your code the turn is over. So the response comes back with actually valid tool call here sitting just like right inside it. But the issue is like the finish reason, like here the finish reason on it says stop when should actually said two calls, and like your loop is just like checking the wrong flag to decide what to do next. So it was just like sees stop, so just like exists from that place, and just like walks right past the call, and it will not do anything with it, just like sitting there waiting to run. So for this specific case, like the work actually was actually done, the tool already produced the desired output, but your loop just trusted the wrong signal and just quit earlier. And if you go one level down, this is also not like common pattern, which and something that driver people deal with consistently, which is like for a piece of hardware it would raise statue bit, and it would sit the done a bit while the transfer is actually still going. So the driver would trust that bit, and what ends up happening is like just like end the read earlier than it should be. So in other words, wrong flag, and trusted like the wrong flag, and it got that's like the same failure here, just like one level down. And for the fifth and the final, like most common issue when it comes to this, or pattern for this one, is like actually the fifth one is the reason like all the other four are able to stay hidden in the first place, which is like let's check exactly this one. Let me zoom a little bit more. So yeah, as you can see here, so here's the trace for the run. So as you can see, check OK, xtail, deliver. So basically based on the trace, the agent kicked off and it reports success. The model spans shows it actually emitted one tool call, but just like go looking for the execute step, and basically there's nothing here. There are 0 of them, so it never ran in the first place, and nowhere in here is anything like comparing those two numbers together. And so basically what ends up happening is the intention is to have one call, but actually it executed 0 calls. And the reason is like there are no checks here, so the drop will just like sail straight through the gates, and it will just like get reported as success. And the flip side of this same gap is just like as dangerous as this one, because the exact same missing check is whilst any tool accidentally run twice, which is maybe super dangerous in, for example, if you're using agents to process payments, etc. And basically, like nobody who's worked on, yeah, and basically like anybody who's actually worked on distributed systems before has actually a name for both halves of this. So basically, you check something, and then you go act on you go act on that thing, but there's a gap in between where it quietly changed, and that's like a time of check to time of use type of bug. It has a specific name for it in distributed systems. And on the other side, if you don't have an exactly like once guarantee, that same message just gets delivered twice, which is also as dangerous as not delivered at all. So basically is like here there will be like no checks at the end, so maybe like a drop or double both, or double like execution would both just like slip right through it. And this is like same failure, just like one layer down. Okay. So so these basically are the five most common ones. And now the real question here is like, how do you figure out which one is actually yours? And the good news is actually you don't have to guess at all here. So basically, like there are five main checks you can do, and you can run them in order. And these checks are ordered from the cheapest and most useful first. And the very first very like first real check does most of the work for you, so you don't have to worry. So let's start with the check 0 here, because it turns out building it is also also like fixes the last cause as well. So for check 0, check 0 is actually super simple. So basically you count what the model meant to call against what actually ran. And right here, so basically like the model emitted one tool call, but the number that actually got executed is 0. So these two numbers should always match together. And nothing like in the system was comparing them in the first place. So that mismatch right here is the entire failure in a single pair of numbers. And the nice thing here is that like this one check does two jobs at the same time. First one, it tells you the bot is actually real, and if you leave it there permanently, it's also like the fix for cause 5. So you should always start by building this specific check here. Now let's move to the next one. For this check, what is actually the big one? It's a little bit more complex here. So basically, like you turn streaming off, and you run the exact same request again, and basically, yeah, that's the whole thing in one setting. And here's actually how you're gonna read the result here. So if it suddenly works, then your problem was like how those streamed pieces were getting put back together in the first place. So for this one, basically, the issue in your system is maybe cause 1 or cause 2. But if it's still broken with the streaming off, then the streaming was never the issue in the first place. And here you would be looking at middleman issue, maybe like a bad signal, or maybe a missing check. So for that one, we're going to talk about maybe your system have either 3, 4, or 5 type of issue. And this actually isn't fixed here, it's just like a test, it's diagnosis, but it's actually the most useful move that you can make, and it's where you should always start. Okay, so here, as you can see, here's like the whole path laid out for you. So we start with the 5 suspects. You would turn streaming off immediately, so that would cut like that in half. And if that worked with streaming off, then you go and just like read the raw stream, and by doing that you see actually this directly. So if empty arguments is if you got empty arguments, then it's cause 1. If it's like pieces landing in the wrong buckets, it's actually cause 2. And if it just like broke both ways, then you call the model directly to catch a middleman, or you go inspect that finished signal. So just by implementing this, like worst case is that's like 5 checks. And I want you to notice here that like at no point in any of that we touch the AI model itself or the AI agents themselves. Okay, so let's talk now about fixing them like in the same order. So for the first cause, the rule here is simple: don't parse it, and don't run it until one thing should be happening before this, which is like until you are sure that the call is actually complete. So the name is there and the arguments are closed off. So basically we should avoid, and we should have robust robust mechanism in our system to detect an empty parse, not like complete parse. That way you would treat empty as wait instead of done. And for this one, actually, I want to be straight with you because it's actually like properly fixed in just like several stacks already, but it's still open in just like one very common Python framework. And there, like the workaround is exactly like what we saw earlier. You just like turn the streaming off for the turns that use the specific tools. That's the simple fix. For the second one, basically what you should do is you need to group the pieces by the call's own ID, and you should do this instead of order instead of like instead of using the order they arrived in, or even like using the index that you will be trusting the provider to get it right. And that way, like if the index does come broken or maybe like all zeros, you just like fix it in small shim before your assembly code ever sees it. And this one is actually confirmed. This is the exact fix for this specific cause. And yeah, that's it. Let's move to the next one. So for the third one, you need to find the middleman by like to find it. You need to pull layers out. You need to pull. Basically, you need to pull like layers out like one by one, but like one at a time until that thing would work. And then you would either pin that specific layer to a known good version, or just like make like a route around that specific layer. So for this one, maybe like format bridge is your prime suspect. So you can pin your versions. So basically that silent update can't quietly bring the whole problem back later on. And this one's is also confirmed too, as actually like real breakages caused by version bumps. And that actually exists across multiple proxies already, and many people are struggling with it. So the next one, so for the first cause, which is like you trust the call, not the flag. So there's like tool call in like there's like tool call in the response. You just like run it, no matter what the finished reason says. And if you happen to know the gateway yourself, you just like fix the wrong marker right at the source. And for the providers, you just like already know they misbehave. So for this one, the confirmation is fixed. And just like loops taking it, like talking to providers that don't follow the specs. That's the whole thing. It's easy to fix as well. For the fifth one, you just like take the account from earlier and you just like make it permanent. So basically you need to focus on intended versus executed, and you need to do that on every single run. And you should also like refuse to call the fixed success when the two don't match each other. And while you're there, you need to make each call safe to run once, which closes off the double run version issue of happening in the future. So this is the one that quietly catches the other four. And before you even like know which one you've got, so if you want to start building a solution, you need to start by building this one first. So basically now once all five of these are handled, here's the same pipe again. The order would get read, it would get assembled, carried, signaled, and this time actually run successfully. And that green success marker here is the very same one from the first slide. And now it's just like finally telling you the truth instead of lying to you. And because right now it will actually run and produce the output, not like before. So now let's just like step back for a second, because I want you to notice something here. So none of what we just did was like prompt change or model change. it was none of about this one. It was all about plumbing and all the data plumbing and the infrastructure of the agent system. So every one of these five problems actually lived right here. Let me zoom in a little bit. So it basically lived in the plumbing between the model and the tool itself. It was never about inside the tool or inside the model itself. So even like the smartest model on earth won't fix this issue. So which means like that thing you were so sure was like the AI model was lying to you, the AI agents were lying to you, almost was never the actual reason in the first place. So basically, like when an agent lies about calling a tool, it almost never actually lied. It was always saying the truth, 99.9% of the times. And honestly, that's the bigger lesson in all of this so far. So the failures that are actually worth understanding are almost never live in the smart part of the system. It always live in the plumbing between each of the parts of the system. And actually finding these issues means being willing to look at every layer, the model, the stream, the protocol, the driver. All you need like to look all the way down to the wires layer, and basically like the same discipline whether there's a model in the system, like there's like an AI model, machine learning model in the system or not. So model to tool, just like mind the channels in between them. That's the summary. And yeah, that's the whole video here. Hope it was helpful for you. And if you need any personalized help, you can just like send me an email, and I'll send you like more personalized diagnosis for your specific case. You can find my email in the bio. Take care. Bye.